Welcome back to the second part in our series on control systems and feedback loops. In our first episode, make sure you take a look, but we got on the same page about what design is. Design is what you do to get from where you are to where you want to be, and thinking about how do you know when you've gotten there, and then what do you do to get there, and what might you adjust along the way. Talked about the concept homeostasis, that our human bodies are regulating many different things. And then we thought about some examples. Also had this visual of a seesaw and also a number line of how you have a certain goal. Something happens where then you want to try to get it back to its place. In this second episode, we are going to talk about terms that are mentioned in the more typical situations where control systems and feedback loops are mentioned in both mechanical engineering and also electrical engineering and computer science. So we've got some new diagrams that I'm going to talk through, and let's just dive right in. I'd like to think that one of the more relatable situations of why control systems are needed is when you are in a room and you want to maintain the temperature. So let's assume that you've got some air condition, and the air conditioner is going to put in cold air as you need it. Then you have a certain desired state or a set point. That temperature is going to be based on preferences and then / comfort. And people will differ in what they prefer, but that's not related to what we need to talk about. The outcome is, what is the temperature? And if you're not used to this sort of system modeling and being very precise, it might seem sort of redundant, but we really need to break it out into these steps, because ultimately a computer, it's going to be automated. So you really need to be explicit about the different parts of your system. Then you're going to make a measurement, and we know that with our thermostat systems, the HVAC systems, there's a way to measure. And then there's a disturbance. These are sort of unexpected or maybe undesired things that come about. So if you're talking about a room, maybe somebody opens the door, and in the case of when you want AC, maybe it's really hot outside, or maybe you have more people in the room, so it's warmer. And then when we talk about the system, the room, there's different characteristics that will affect the temperature. Just like before, feel free to pause the video to try to anticipate what I'm about to share. But in your room, you could have different types of insulation along the walls. Maybe you have materials, right? If you think about the thermal conductivity of materials like metal versus plastic versus wood, it's all going to be kind of different. So that sets up the situation. So let's take a look at how our factors here map to this diagram. And this is going to make more sense as we go along. So at the beginning here, you have some sort of desired state. And remember, we go back to our definition of design. That desired state is this future preferred situation. So this is what you're aiming for. That's your goal. And then the next step, and we kind of have to go around once for this to really make sense. But actually, no, we'll start here. This actually makes a bit more sense. You want to measure where you are at. Now, if your desired minus your measure is 0, then you're all set and nothing needs to happen. But so long as there is a difference between those two, then you will then take some sort of action to adjust. So let's say the air conditioner is going to put in some cold air. It's going to take some time for the room, all right, the system, to spread all of that cold air. And now, right now when we're talking about this is a snapshot in time, but these are all real-time systems. So it's sort of measuring continuously, and it's a bit hard to conceptualize it that way. So let's just pretend like we're slowing down time a lot. So you turn on the AC, it goes out throughout the room, and then at some point you measure it, and you see how much more you need to adjust. And then here you could say this is the outcome. Okay? So let's take a look at it sort of in a different way. We've got what you want, which is this desired, minus where you are, that's the measurement, and that's going to equal some sort of distance. You are aiming for 0. Because when you have this difference is 0, then you're all set. In the case of temperature, it's the temperature value. This is then going to be related somehow, multiplied or some other sort of math, to then adjust, take some sort of action. That action is going to happen on the system. There's going to be another outcome. You measure it, and you keep doing this over and over and over again. All right? Let's take a look at some terminology that is more often used. And in trying to teach this in contexts where it's not specifically engineering, I'll interchange terms and try to pick things that you can relate to more, just sort of from everyday language. So you have an input. You're like, I want this temperature. You have some way to measure it. So you have a sensor. Then you're going to have a controller that's going to adjust the values. Sometimes we call the system a plant, kind of like a power plant. And then if we have input on one side, then of course we have output on the other. Okay, so let's, with this framework, all right, maybe this makes sense, maybe not. Let's talk about some examples that we talked about in the first episode. So what about speed? So you're trying to get to a certain point. So you have distance. How far do you need to get? Time. That's how much time you have left. So if you're in a rush, you are going to increase your speed. However, what are things that might come along the way that would deter you from really adjusting a lot in order to get to your goal? Now, actually, in this case, I'm sort of mixing metaphors here because really you're not going for a particular speed. Okay, but let's just sort of keep going with this everyday example. You might have things like road conditions that might slow you down. Right? You don't want to speed on something that's harder to drive on. Maybe you have police or radar in the area, so you don't want to get caught. All right, and so if we just focus on speed, cruise control is this feature where you can have a set point. All right, you're going on the highway, there's not many cars, you don't need to take an exit anytime soon, so you put in a set point, let's say 55 miles per hour. So then your car is always going to be measuring how fast you're going. And if it's not 0, it's going to either speed up or slow down, and then keep adjusting that to try to maintain this desired point. Now, if we want to get into how it actually works, then we're going to have to see how does a car accelerate and move forward, or how does the air conditioner put the cold air out. But right now, we're just sort of speaking at this abstract level. We talked about sort of more, I guess, non-technical examples, right? If you think about behavior, all right, or grades in school, all right, there's certain expectations for how you behave, all right? That's that sort of desired thing, where you're trying to get a certain marks, certain grades. And this sort of measurement, all right, those are sort of tests or quizzes, or maybe just teachers or parents telling you, hey, you're a little bit off, so now you need to adjust your behavior. We talked about food a lot, all right, whether it's setting the environment, again, with the oven or the fridge, all right, but then with food and with other things, you have to wonder if it's reversible, right? So if you overcook something, if you undercook it, that's probably okay because you can add some more to it. But often when you overcook something, you are doing some irreversible actions or quote-unquote damage to things. And then we also talked about, in terms of sort of interpersonal, intrapersonal things, we sort of have health, right? If you're trying to get stronger, or maybe you're trying to lose or gain weight, you have a certain goal. You're going to do actions. You're going to see how the complex system responds. You make that measurement and try to really strive to meet your goal. And maybe along the way, you're going to adjust the goal. Okay, so I think we get to a good stopping point. And then in part 3, we're just going to sort of wrap it up, reiterate what we've talked about, and share just yet another related concept to try to really solidify these concepts in your mind. Thanks for listening, and we'll see you next time.